Hi all, already I have discussed the difference between scalar quantity, vector quantity, various examples, types of vectors and how a vector can be represented using east direction, west direction, south direction, north direction, positive x-axis, y-axis and also I cap, j cap. I have left out some minimum types of vectors that I think in this class will be automatically discussed through this. So this is basically vector multiplication. Actually in the syllabus you will find after types of vectors and representation of vector, you will find vector addition. But why I am taking this class before vector addition, that is very important because these things is directly related to physics. So far we have discussed so many vector things. It's a mathematical kind of things. You might have felt that sir is teaching us mathematics. No, I want to show you the exact application of the vector things in physics. So our most common chapter is work per energy. So I am going to derive the formula for work here. So through this only you can understand. I am trying to keep all the syllabus intact, I mean compact, so that with a small effort you can understand. Okay, so vector multiplication. Vector can be multiplied in two different ways. One is dot product, another is cross product. In my next video I will discuss about cross product. Let us concentrate or let us restrict our discussion up to dot product. So dot product, the other name is scalar product. Why? Because if I multiply two vectors in dot product way, then I will get a scalar quantity. Even if I am going to get, even if I am multiplying two vectors, but I am going to get a scalar quantity. That's why the name is scalar product. So for example, and the formula for this is very easy. A dot B equal to AB cos theta. The definition is also simple. Dot product of two vectors is equal to the product of their magnitude and cosine of the angle between them. Okay. So theta is angle between A vector and B vector. So I am giving it as equation 1. Let me move little bit away from this because I am going to use some special cases. So before that I have to discuss some more types of vectors. So I am again coming back to types of vectors. I have discussed zero vector, I have discussed unit vector. Then the next types are parallel vectors, and here anti-parallel vectors. Parallel vectors, anti-parallel vectors. No need to write any definition, anything, just watch my diagram. Let's say this is A vector, this is B vector. You can easily understand. Let's say this is A vector, this is B vector. So observe, what is the basic difference between these two diagrams? Here, I am not talking about magnitude, just in terms of direction. Here both the vectors possess same direction. So I can write, when two vectors are along same direction, or when two vectors are acting along same direction, then the two vectors are said to be parallel vectors. But here, opposite direction. When two vectors are opposite to each other in direction, then the two vectors are called anti-parallel vectors. But this is a way to talk about parallel vectors and anti-parallel vectors in language or using English. But we are interested to learn what is the basic difference between parallel vectors and anti-parallel vectors using mathematics. So since two parallel vectors are along same direction, so angle between, remember this, angle between two parallel vectors, is 0 degree always. How? Look, this is my A vector. I am shifting this without changing its magnitude and direction, and from here I am again using this. So AB. So A is making no angle at the tail region of A. This is the tail region of A, no angle. So it's a 0 degree. But in case of opposite direction or in case of anti-parallel vectors, angle between, you can pause the video and also dictate the notes if you want. Angle between two anti-parallel vectors is 180 degree. So let me draw the diagram for this. So without changing the magnitude and direction, I am shifting this vector, A vector, and also without changing the magnitude and direction, I am shifting this B vector. Now this is the tail region. of both the vectors. Now the angle is 180 degree. So I think if you understand these two diagrams or four diagrams, then things will be clear. So two parallel vectors are having direction same, angle between them is 0 degree. Two anti-parallel vectors are having direction opposite, angle between them is 180 degree. So